So does this equivalence of hypotheses mean that all of astronomy is relative? That while the numbers and the math must be right, there is no real way to know whether the planets go around the sun or vice versa? Well, surprisingly to us today, that thought didn't particularly trouble most thinkers of Kepler's time. Technical astronomy, involving the calculation of observed planetary positions in the sky, was a branch of mathematics, while cosmography, the theorizing of what might physically be taking place out there, was considered to be a distinct discipline. The job of an astronomer, foremost, was to calculate where spots in the sky would appear, but a physical theory was not essential to that endeavor. Kepler had long been convinced that the way to resolve the conundrum and to show the truth of Copernicus's outlook was to determine the physical causes of the motion of the planets. And he had thought since his days in school that the sun itself caused the motions, instead of sitting near the center watching them like a couch potato, as Copernicus's sun does. To show the importance of the sun, Kepler proved that there was a difference that was not equivalent, a difference that was not just a matter of opinion. He calculated the difference in the orbit of Mars if the actual sun were used to determine its characteristics, rather than the center of the Earth's orbit. The difference was over 1 degree, which was definitely observable. After having proved that using the real sun makes an observationally different model, Kepler concludes part 1 of his new astronomy, ready to create the first truly sun-centered astronomical model, intent on proving the true role of the sun in the motion of the planets.